Mhm. Right, so welcome everyone, and marhaba. I want to wish happy Eid to those who are celebrating, and I'm so, apologize because I have to speak in English. I have a very special guest today, and actually this session was supposed to take place before uh, now, but for whatever reason it was not done. So we
My
figured
fault.
uh, it was um, who better to host than uh, the one and only Josh Long. Josh, as you, probably all of you know him, he is. I'm going to introduce him for a few seconds, but of course he can spend more time. But he is obviously a Spring developer advocate, Java champion. He has lots of books, podcasts, basically everything about Spring. Um, yeah, so I'm very excited to be hosting him. And I was just talking to Josh a couple of minutes ago. He is going to be in Spring IO among other conferences this month. So it happens that I'm going there. So I'm very excited to catch up with him. Um, so yeah, looking forward to that. Um, before we start, I want to say that the session is being recorded. Okay, so if you miss it, you can catch up on YouTube. And at the end, we will have like few minutes questions and answers. So feel free to use the live viewer chat on YouTube to ask questions. You can ask questions in Arabic, either in Arabic or English. It's fine. I'll try my best to translate it. Um, and yeah, that's it. So that being said, I'm gonna turn it over to Josh so that we can get things started. So, Josh, session's now in your hands.
Very good. Thank you. Thank you so very much. Can you hear me? Just to confirm, we're all good. You
Yeah,
can hear me and everything. All right. Very
yeah, I
good.
can
So
hear you.
yeah, I am so sorry we could not meet last time. That was my fault. I hope it will not happen again. I am very honored, very pleased and proud and happy to be before you all today. I was so excited when I heard about the creation of the Arab Jug, and I reached out as soon as I saw the tweet saying it was going to exist. I said I would love to. I would be honored. Please consider me. I could, if you have an open spot, I would be very humbled to have the opportunity to speak, to your group. So thank you for the opportunity. I'm sorry that I ruined it the first time, and I'm very grateful to be here this time. My name is Josh Long. I work on the Spring team, and I have since 2010, so almost 12 years now. I am a Spring developer expert, a Kotlin Google. Spring developer advocate, a Kotlin Google developer expert, a Java champion, and very importantly, I am at your service. So if you have questions or comments or feedback or whatever, please don't hesitate to reach out to me. I have a book that I've just I'm updating right now. It's called Reactive Spring. I have a blog. I do a YouTube series called Spring Tips under the Spring Central, the Spring YouTube channel. So if you go to spring.io/video, you'll find all of our videos, and there's thousands and thousands of videos there. And then I have a series in particular, a playlist called Spring Tips, and you can find those videos there as well. I have a podcast every Thursday. That's today, my friends. It's today for much of the world. In fact, it might be for everybody. What is it? What time is it in New Zealand? Time in New Zealand.
In Wellington, New Zealand, it's 21:14.
Yeah, so that's almost. I mean, I'm pretty sure it's still today for most of the world, right? It's still Thursday because it's very early here in the States, in the west coast of the States. So it'll come out later today, my time. It'll come out early morning on Friday for most of the world. And then, of course, every now and then I'm on Twitch and I'm on the internet. So if you have questions and feedback and whatever, I'm happy to engage in a conversation. You can find me on Twitter. You can find me on LinkedIn. And, of course, you can find me via email. So please don't hesitate to reach out. Now, one of the things that I have long worked on, that I've always strived to work on, is making it easier for people to build applications intended for production. I know that people struggle with this. They want to go faster. They want to deliver better value, better software into production, and they are looking for ways to do this. But of course, they struggle because it's hard to build reliable software. You cannot just go quickly. Going quickly without a safety net, without safety measures, is dangerous, right? Any idiot can drive a Ferrari right into a wall, right? That's not what we want. What we want is to be able to do speed at, go at speed and have safety, right? And a lot of organizations understand this. They know that speed is very important. It gives them a distinction in the marketplace of ideas. It helps them to better position themselves relative to their competition. And they look for ways to go faster. And of course, in this large ecosystem, there are so many different things, especially in the last 20 or so years, that make it easier for us to go more quickly as organizations, right? Things like test-driven development, things like microservices and continuous integration and continuous delivery and containers and just all this stuff, right? And really, cloud computing in general, I mean, all these things are not very interesting. They're not technically novel, right? It's not like, it's not that we did not have, rather, we had a way to deploy software before, right? We had a way to deploy servers before. What is new here is that now it's very quick. You can press a few buttons and you get servers, press a few more buttons, or do nothing at all and you get your updated code into production. That's the novelty here, is the speed at which we are able to execute. And that speed is valuable because the faster we are able to deliver software into production, the faster we are able to validate with feedback and from input from our users. We're able to validate that what we have built is what they wanted us to build, right? It's the right thing. And if it's not the right thing, because we're moving quickly, we can fix any issues in the code and respond quickly. So our code grows and improves faster than the competition. So we look for ways to go quickly as an organization, to learn quickly as an organization. And we look at all these different technologies, things like microservices, like test-driven development, like continuous integration, cloud computing. We look for all these things that we can do. There's also the rule of 5, 50, and 500, which I think is kind of related. 5 is supposedly the number of things that you can keep in your head at one time, in your brain at one time, right? Your mental RAM, the things you can keep details about at the same time. And this is why if you have a morning stand-up and you have to listen to more than 5 different things every morning, you're going to forget some of it, right? That you won't be able to remember all the details. But 5 people, it's easy to remember that in a stand-up. It's easy to keep in your head what everybody in the team is doing, right? 50 people is basically the number of people you work with and you interact with on a daily basis, right? This could be your family and your friends and your workmates, the people that you work with closely. And then 500, that's the number of people that basically you keep in your head, but that you don't interact with all the time, right? These are, your distant relatives, perhaps, or friends that you haven't seen since school, or people that work at your company, but you don't interact with them because they work in another office far away, or something like this, right? And so you still know who they are. If you saw them, you'd remember, but it's not like you talk to them every day or even every month. So this number, I think, is kind of important too, because 5 people, 5, 6, 7 people, that's how much you can keep in your head, right? If you have a small team and you can remember what everybody's doing, then you don't need a lot of meetings with all these people. You don't need to have a conversation to tell this team what you're going to do and then have the same meeting with another team to tell them what you're going to do and synchronize everything and do flag day upgrades and software deployments and rollouts and all that. It becomes much simpler to keep in your head, in your mental RAM, what is happening. So small teams are good, and microservices and these kinds of things they support these kinds of things. We want small teams. We want to learn, to improve, to go quickly. Once we look at different technologies that allow us to do this, we find things like microservices, right? Microservices are not, as I say, they are definitely not a technology pattern. They're a people pattern. They're a way of organizing your organization so that you can benefit from velocity, right? And if you keep in mind that the goal here is to optimize for speed, then a lot of things become obvious. They become a natural consequence of that decision. So things like continuous delivery, test-driven development, etc., are all about fast feedback cycles. When you move to microservices, keeping in mind all the stuff that we have just talked about, then you get some benefits. You get velocity, even though it's more complicated, right? Microservices require a lot of redundancies. These redundancies create problems. So, for example, I don't know, how many of you have been to Changi Airport in Singapore, right? Changi Airport is a world famous airport, beautiful, beautiful airport, and it's famous for just being very pleasant. Singapore, for those of you who do not know, is a very small country. There is no such thing as an international flight as a long distance flight in Singapore, right? It's not possible. Every flight in Singapore is an international flight. If you get on a plane, there's no way you're going to fly from one side of Singapore to another. As soon as you take off, you've already left Singapore, basically. So every flight, by definition, is an international flight. You're going to leave the country. Otherwise, you would just drive. It would take half an hour, or an hour maybe. So when you go to the airport, it's an international hub. Lots of people transiting through this hub in Asia, and people love it. A lot of people go to this airport, and it still has a very good rating, a very good ranking among all the airports in the world. Usually it's the number one, right? Depends on which year, but most years that I have seen, and I have been traveling for a long time, most years I have seen it's the number one airport in the planet. And one of the things I think that people so love about this airport is that it has redundant infrastructure, okay? So in the same way that when you move to microservices, you have to have redundant infrastructure, things like security, load balancing, routing, configuration, observability, all that has to be specified for each microservice. In that same way, you have redundant infrastructure in Changi Airport. What I mean by this is when you go to the airport, you can get inside the secure area very, very quickly, right? We're kind of secure. You have to show your ticket and then you walk in. It takes no time at all. There's no x-ray, there's no security, there's nothing like that, right? So you can walk in, you can go shopping, you can go to the garden, you can do all these beautiful things inside the airport. And only when you are ready to go to your flight to board the plane do you go through the x-ray machine, right? As you go through the x-ray machine, people, the usual things happen. You go through the x-ray, they scan your bags, they scan you, and then you sit on the plane and then you board very soon and you fly away, right? So this all happens very, very quickly. And you never feel like the airport is wasting your time, right? A lot of times, like here in America, there are several airports where they just waste your time. You can go to, the Atlanta airport, ATL, or Chicago's airport, or Los Angeles' airport, where I'm from. These airports take forever. It'll take hours, Imagine you take a 10-hour flight from, Western Europe, and you fly to California, where I live, and then you spend 2 hours just trying to leave the airport once you have landed, because you have to queue through security in Los Angeles or something like this. It's, and clear immigration and all that. It takes forever. In Changi, you don't have this. It's very, very quick. And the way that they have achieved this, one of the ways they have achieved this is by having security, x-rays and all this at every single gate, right? Every gate has security personnel. Most airports, when you enter, there's one big area where they have all the x-ray machines and all the police officers and all the security all in one place. And so everybody that wants to go into the airport has to go through this one area. It becomes a bottleneck. It's a monolith, right? You have all changes that go into the system going through one thing, one corridor. This is problematic because it means that you get a choke point, right? Things slow down there. At Changi Airport, this is not the case. You go, the queue to board the plane, the queue at security is never going to be longer than the number of people that are on the plane. So if you have 100 people, that's the largest group of people that you will have to worry about at the security gate. You don't have to worry about thousands of people boarding all the different flights. This means that for each person in the airport, the experience of getting on a plane is actually faster. It's much faster, right? Because you get concurrency. And of course, this costs more. It's more complicated for Changi Airport to maintain, many different security staff, many different X-ray machines, and all this. Of course, it's expensive, but the result is velocity. Everybody at the airport feels like they're going faster, and they are going faster, right? Their queue time between entering the airport and getting on the plane is provably less than many, many other airports all around the world, and even all around Asia. So this is basic queue theory, and it applies to microservices as well. Yes, you have redundant concerns. You have to redundantly specify security, load balancing, infrastructure, deployment, observability, all these things each time you create a microservice, but they allow you to deploy changes more quickly than a monolith will do, right? If you have a big enough team. If you have a small team with five or less people, then maybe a monolith is just fine, right? It's just when you're trying to scale that team, that's when you start to realize that microservices might give you more velocity, more throughput. Now, when you do this, you have to have a way to provide all these different services to your code quickly, right? If you have to re-specify this for every microservice, then it will take forever to go to production. I remember going into different organizations and finding this one wiki page with 500 easy steps to production. So for every new service that you wanted to build, you had to go and fill out all these different steps to build software that could go to production, and it took forever. So you would remember the last time you created a service because there's a Maven archetype, and you have to do all these thousands of different things, copy and paste this code, change this, do that. Very, very slow, right? And of course, if somebody decided that they should have some sort of new instrumentation or something like this, the whole organization had to change their code in dramatic ways, right? This doesn't work. So a big part of the success of moving to production in a cloud-like environment where you can take advantage of microservices is having the ability to very quickly spin up this redundant infrastructure. Spring Boot provides something called auto configuration. Auto configuration does most of the work, but there are still some redundant things that you need to specify in the infrastructure. And here, I think Kubernetes is actually a really nice choice. So today, my friends, we're going to talk about a lot of different patterns and things that you should care about when you're trying to build microservices intended for deployment in the cloud on top of something like Kubernetes. And of course, to do that, my friends, we're going to do as we always do. We're going to go to my second favorite place on the internet, start.spring.io. My first favorite place on the internet, of course, is production. I love production. You should love production. You should go as early and often as possible. Bring the children, bring your friends. It's the happiest place on earth. It's better than Disneyland. But if you have not been to production, you can begin your journey here at start.spring.io. I'm going to use Java 17. I love Java 17. Java 17 is the current long-term supported version of Java. It's amazing. It is faster, more robust, more secure. It has more syntax. It's technically superior to Java 8 in every way. It's also morally superior to Java 8 in every way. You will not like the look of sadness on your children's face when they see that you're using Java 8 in production. Don't do it. Be the change that you want to see in the world. Do the right thing. Use Java 17. Java 17 is the right thing to do in 2022. And if you judge Java 17 purely by the number of the version, then it is more than twice as good as Java 8. And I think that's important to remember. Java 17 is awesome. Java 18 is even more awesome, but I'll be happy if you stay at Java 17 because, among other things, it's also the same version as GraalVM. GraalVM has a native image compilation mechanism that is a little bit slower to upgrade the syntax level. So Java 17 is a fine place to put your code these days. We are going to use Spring Boot 2.67. We're going to use R2DBC and the Reactive Web and H2 and the Spring Boot Actuator and Spring Native. Okay, so we're going to hit generate, and that's going to give us a new zip file that I'm going to open up in my IDE. I'll be right back. I'm going to let that import. I need water. Okay, I'm back. So we have our brand new project, and our project is a public static void main application. And we're going to talk to a SQL database, an in-memory SQL database. I'm going to create a type called customer with a field called name. And this customer type is just a regular record. It's going to be an entity using Spring Data R2DBC. We're going to use a reactive repository. Now, reactive repositories are, they use reactive programming. Reactive programming, I think, is the only kind of IO style that makes sense in a cloud environment. Reactive programming gives us three big benefits. The first is resource efficiency. That is to say, you can better reuse threads so that you can handle more scale. You can handle more requests at the same time. And it does this by embracing asynchronous I/O, non-blocking I/O. This has the effect of letting the runtime move your code onto threads when there is something to do, and then taking your code off of the threads, off of the CPU when it's waiting for something, right? So this is a good deal because now you're not sitting on a thread, not doing anything, but not freeing the thread up for somebody else in the system to use. This is the first benefit. The second benefit is that you get ease of composition. With reactive programming, everything is a reactive stream. And so because it's all reactive streams, you don't have to think about where the data comes from. Is it coming from Kafka or a web service or a WebSocket or RabbitMQ or JMS or from an RSocket endpoint or GraphQL? It doesn't matter because you have one type, one abstraction called a publisher. There are two specializations that we will look at called mono and flux. These types are specialized versions of the publisher reactive stream type. But basically, because you have one abstraction, it doesn't matter if you have a small amount of data that you consume very quickly, or if you have an infinite amount of data that gets sent very quickly over a long period of time, or if you have a little bit of data that's sent over a long period of time, or anything in between, right? The cadence, the frequency of the data, the shape of the data doesn't change the abstraction, right? That's important here. You have one kind of thing, one type called a publisher. And because of that, these things compose well. You can add them together, you can flat map over them, you can filter them, you can do all sorts of things with them, including flat mapping and zipping and so on. This makes it very easy to think about higher order algorithms, to think about higher order composition, instead of constantly thinking about how to glue one API to the other, how to take data from this service that is sent over the Kafka API, and then take that data, which doesn't look like a Java collection, right? It doesn't come, you can't read the data from Kafka as a collection. It doesn't make sense. You have to read it in this asynchronous callback-centric style. When a new message arrives, call me back, right? Then you have to take that data and send it over here to this WebSocket endpoint, which doesn't understand what you're doing over here in Kafka. So you have to write glue code so that you can take the data from here and put it in a place where the WebSocket endpoint can get it and then serve it up, right? This becomes very tedious. Maybe you have a Java util queue and you're doing pull and pop, and it's just life cycle code that you have to write yourself. that goes away if you take advantage of reactive programming, because you have one type called a publisher. The third benefit of reactive programming is that you get ease of robustness, right? How stable, how scalable, how resilient can you make your services? Reactive programming has built-in support for something called back pressure. Back pressure is very simply flow control. It has to do with what happens when one side of a conversation, one side of an interaction goes faster or slower than the other. If one side if one side is giving too much data and the other side cannot handle it all, it'll fall down, right? And it'll make the service unavailable to the endpoint and to the consumer. This is a problem. So what we need is some way for the consumer of the data to push back, to say, no, I don't want any more data, please. I've already got too much, and it's not okay for me to continue taking on more. This creates a service that is more stable. It will not be overwhelmed. And we call this back pressure. These reactive APIs also have, it's one type, right? It's easy to compose. And it's also nice because we have a single place where we can add support for things like retries and timeouts and error handling and so on. This means that a lot of the code that you have to write to build reliable services, you can just throw away because it's all just built into the Reactor library that we're going to use for building reactive APIs. So resource efficiency, ease of composition, and reliability. These three benefits make building reactive services just a natural. They make life much simpler because you have less code that does more than you would otherwise, right? I'm excited about Project Loom. Project Loom will help us with that first point, that first goal here. The first goal is to make it cheaper to create threads, or make it cheaper, make it so that we can reuse threads to handle more scale. Project Loom will allow us to create more threads cheaply and therefore to handle more scale. Unfortunately, it doesn't help with the other two benefits. It doesn't help with ease of composition and robustness. And that's a shame because I love Loom. So Project Loom and Project Reactor will work very well together, I think. These things will support each other. So today, whenever I build software, I always use reactive programming. It's just a better fit for the cloud where resource consumption costs money, right? If you build inefficient code, it can cost money. So whenever you can, if you can, you should take advantage of ways that optimize for that. Okay, so we have our reactive API, and we have this entity type, and I want to build a simple controller, okay? And I'm going to say customer HTTP controller, and this will be at response body, and I'll say private final customer repository, and I'm going to inject this into the constructor, voila, and I want to return the data when somebody asks for it. So customers, publisher, customer, get customer, return this dot repository dot find all. Okay, so there's the customer repository. I need some sample data for us to look at, so we'll go here. I'm going to create a new file called schema.sql. Here, we'll create a table called customer, ID, serial, primary key, name, varchar 255, not null. Okay, good stuff. And we're going to create a new file here called data.sql. And we're going to insert into the database some people on the Spring team, just some names of people on the Spring team. Okay. Okay. Dr. Sire. Who else is Stefan? And of course, I'm Josh. So that's 8 names of people who are on the Spring team. We have some schema that will get created automatically when the database starts up. Let's go ahead and run the code to see what we get. Okay. Sorry. it's what time is it? It's 3 in the morning almost, but the lights are very bright. Whoops. Hello. The lights are very bright, and so I am I'm drinking a lot of water. Okay, so we have our HTTP endpoint. Let's confirm that it's working. Localhost 8080/customers. There we go. It's worked. We have our data. Of course it worked. That was always going to work. This was a demo. There's no question that this would work. What we care about, however, is getting this software to production. And the first thing that we care about when we care about production is observability. So in my Maven build, I have the Spring Boot Actuator. The Actuator is a set of managed HTTP endpoints that gives me information about the service itself. So for example, I'm going to include all the HTTP endpoints just for our demo. I'll show all the health details. I'll include Kubernetes probes, and I'm going to include the info environment, okay? So let's go ahead and restart and see what that gives us. Okay, localhost actuator. There we are. So these endpoints give us information about the service itself, the beans in the object graph, the objects in the object graph and how they relate to each other, the caches in the object graph. These are cache manager implementations that talk to things like Hazelcast and Apache Geode and GridGain and EHCache and a coherence and everything, right? All these different caches, distributed or otherwise. We've got the health endpoint, which we will revisit in just a second. We have the info endpoint, which we will revisit also in just a second. We have the conditions endpoint, and the conditions endpoint tells us about all of the tests, all of the conditions that Spring Boot evaluates when the application starts up. These conditions are tests that Spring Boot executes to determine if a certain thing should be enabled. So, for example, if there's a condition that finds code from Hibernate, then we assume you want Hibernate configuration, and so we activate that auto configuration. These conditions are how you can understand what state your application's in. We also have the config props endpoint, which tells you all of the different properties that you can use to change the behavior of the application. So management.endpoints.web.exposure.include is equal to asterisk, right? So if you go here, management endpoints web exposure include, go here, there it is, right? It's already equal to asterisk, but you can see that that's a property that we could change. It shows you the properties that are there and the things that already have values. All right, and we have the env endpoint. This shows you your system variables and system properties and this kind of stuff. And we have the heap dump and thread dump, which you can use to profile your application. We have the loggers endpoint, which shows you all the different log levels assigned to different logging groups. You can post to this endpoint to dynamically change the log level of your logger. We have also the metrics endpoint. This metrics endpoint is a set of managed statistics, things like the uptime, the health, the number of HTTP requests, etc. These statistics are being collected in the JVM, but you can easily publish them to a time series database of your choice by using Micrometer. Micrometer is a vendor-neutral application metrics facade that was created by the Spring team that has different integrations for AppOptics, Azure Monitor, Netflix Atlas, CloudWatch, Datadog, Dynatrace, Elastic, Ganglia, Graphite, InfluxDB, JMX, KairosDB, New Relic, Prometheus, which is very common in Kubernetes, SignalFX, Google Cloud Stack Driver, StatsD, and of course, VMware Wavefront. All of these are very popular, very useful metrics time series databases that can give you the ability to visualize things about your application, to see trends over time with a single pane of glass. So these are in the JVM, but it's very easy because all of this is powered by Micrometer to also publish it to a real time series database. Now, I said we're going to talk about health and info. So let's return to that. The first is info. Info, as you can see, is empty. You can specify something that should go there. So you can say message equals hello Arab jug, right? Like this. And then restart. And that'll create a message that you'll be able to see here in the output of the JSON there. Now, you can also contribute you can contribute changes to the build itself. Oh, this is the JDBC driver. We don't need that, right? Goodbye. You can also contribute changes to the build itself by using the git commit ID plugin. So git commit ID plugin, and you just copy and paste all of this to your pom.xml, and down here. Very good. So I'm going to just leave that there. I'm going to re-import. I'll go to the console. And I'll say rm rf target maven skip tests clean package. Okay. So all I'm doing is I have to make it a Git repository. Git add, git status, git add dot git ignore, git commit -a, YOLO. Okay, so now build it one more time. It's going to detect all of the changes that are in that Git repository, and it'll create a file called git.properties. The indexer has not picked it up, so you have to go here and find it the old-fashioned way by clicking around. There's the property file, and you can see it says, oh, the host is this one, this happened in this time, here's the email, the name, the git commit ID, the tag, all of this, right? That helps you understand when the application was built. So let's restart the application now. You know, we've made those changes and generated this property file. Now we'll go here and you can see the branch, the commit ID, the time, etc. So now it's very easy to go to a service and say, what version of the code is running in production right now? Ah, okay, this is the code that was on this branch that was contributed by this person at this time with this commit ID, etc. We also have the health endpoint. The health endpoint shows me all the different subsystems in the application that might fail, your database, your file system, etc. And so these gives you the aggregate status up, you know, down, etc. All that information that you need to understand the state of the service. If any one of them fails, then this will say down. And instead of giving HTTP 200, you'll get HTTP 500 or something like that, okay? Now, we have the ability to contribute our own health indicators. Let me delete that because it causes intelligent problems. We have the ability to contribute our own health indicators. So we say health indicator, like this, return new health indicator, and health dot status I heart production dot build, right? So there's this. Very good. There's my custom health indicator. You can also change those health indicators if you want, but let's just look at that and see what that gives us first of all. Okay, there it is. I love production. Now, there's also two special endpoints here. There is liveness and readiness. Now, liveness and readiness are for Kubernetes. These are for liveness and readiness probes, okay? So when Kubernetes starts up a service, it asks the readiness probe if the service is ready to start serving traffic. If it is, and it's okay, then it stays in production, it stays up. If something goes wrong and it's no longer alive, if it's sick or if it's not doing well, the liveness probe will start to fail. And then, the container orchestrator will try and take the application and take it out of production. Now, these probes are, you've seen me automatically get these probes for free, but you can influence the behavior of those probes easily, right? Anywhere in the application context, you can publish messages. So let's do that. Let's say at response body. And I'm going to have I'll just have a little endpoint here down. And I'm going to use this convenient mechanism in Spring called an application context event. You can publish events from one component in the context to another very easily, asynchronously. So here, I'll say I want to use the context and I want to publish a liveness state is broken event, okay? So it's going to publish this event to all Spring Beans in the application context that want to listen to this availability change event. And of course, you can write code that does that, right? You can actually, let's say I go here and I say at event listener, availability change event dot class void down public void, right? Something, where availability has changed. And actually, maybe it's even easier just to put it here. Okay, and we don't need to specify it again here. So there's that are.getState.toString. Okay, so here I'm creating a listener to listen to that event that I'm going to publish here. Okay, by just calling that down endpoint. Let's go ahead and restart. Okay, so liveness says up. Let's copy and paste this, go back to this, go down, and it says down there. And you can see when the application started, it was correct, accepting traffic, and then we changed it later on, and it said broken, right? So that's the benefit of that application context event. You can actually make your service, asynchronously. You can tell the service to stop accepting new traffic by registering it sick. And if you look at the status, curl -v, you can see the HTTP endpoint responds HTTP 503 service unavailable, right? Okay, so there's something wrong, right? What happens now? Well, the container orchestrator is going to take that service out of production. It's going to try and create a new instance probably. In Kubernetes, this is a pod. Pods have liveness and readiness probes. This pod, it's going to, when it gets deployed, it's going to handle traffic. And when the container orchestrator tries to take it out of production, we have to make sure that traffic gets cared for correctly. We don't want the container orchestrator to just kill the pod while we are serving HTTP traffic or online traffic. And so we have to set up Graceful shutdown. This is a two-part problem, right? We have to tell Kubernetes to give us a little bit of time between when Kubernetes sends a SIG term signal to the container, to the pod, and between when we get a SIG kill command, okay? You can specify that to be like 30 seconds, for example. And then you have to tell Spring Boot that you want to have Graceful shutdown as well. So let's say we are going to do Graceful shutdown, server.shutdown equals Graceful, okay? And then we want to specify that we have 30 seconds in between SIG term and SIG kill, okay? So that way, during this time, if we have traffic, if we have HTTP requests that have not been completed, then we will wait for 30 seconds before shutting down the Spring application context. Spring Boot will also automatically stop accepting any new HTTP requests. This means that we can finish what we have already started and then close down gracefully. This is why we call it Graceful shutdown. Now, we've got configuration here. Obviously, when you're deploying this application to production in Kubernetes, you're probably going to have some configuration that you want to live in the application context, in the application environment, not in your Java code. So one thing that we can do is read that configuration from Kubernetes itself as either environment variables or as a config tree. Basically, in Kubernetes, you have the concept of a config map or secrets, and these secrets can be mounted as either environments or volumes in your pod. And if they're a volume, Kubernetes does this weird thing where it'll take the keys of the value of the entries in your config map and create files in a directory on the volume, and then the contents of those files will be the values of those entries in the config map or the secret. Okay, it's a little bit weird. So let's see an example. Okay, let's say that we have a directory here on my desktop called config. Yeah, and here we have nothing in it. And I want to now create a new file here called we're going to call it server.port. Okay. Emacs server. Actually, just echo 8081 server.port. Okay. So it's a property file. It's just a text file, but it has a different value than the default. The default is 8080. Okay. So I want to use that configuration. I want to import it by using the Spring config import mechanism. I'll tell it to go to the home directory, desktop /config. This last parenthesis here, this last /, very important. Do not forget it because it'll cause weird errors. Okay, so let's see. So if this works, then even though we have defined this to be 8080, because it's going to read the configuration from the config tree, the directory structure, it'll start up on port 8081. So not 8080. Let's try. Okay, there's our application on port 8081. Now, of course, what we have done here is we have a lot of configuration values, but only some of these values are for Kubernetes. So what we want to do is to change our application to load configuration dynamically based on the platform it's in. Okay, so what properties are Kubernetes only? Well, the probes, I think, is Kubernetes only. The configuration is. The server port, that should be general. Maybe we can have a separate property here called hello .yaml. Okay, there you go. So that's how we know it's inside of Kubernetes. We want Graceful shutdown. That's Kubernetes. Same thing for that. So what we can do is we can create a special section using the --# operator. So we can have an activation on cloud platform equals Kubernetes. So everything after this special syntax here will be activated only if we are running in Kubernetes. So down here, it says hello arabjug.yaml. Up here, it says hello arabjug. Let's see what happens. And if this works, then we should see that it starts up on port 8080 again, not 8081. Okay, good. So here's the application. Did I change something? /actuator, good. Customers, there we go. Yeah, so there it is. There's our endpoint. It's working here. We have the health endpoints as well, right? Health, but we don't have the Kubernetes probes, right? Those probes are only available when we're in production on Kubernetes. So I can do liveness, it doesn't work, right? I have to have the Kubernetes configuration. Okay, so now let's bring back Kubernetes. And you can do this by setting a property. You can say the cloud platform equals Kubernetes. Okay, go down to here, save it, and modify the options. Okay, program arguments -- spring main cloud platform equals Kubernetes. Hit OK, and then restart. Now, of course, this is good for development on your local machine. If you're deploying to Kubernetes itself, you don't need to do this, of course, because it'll automatically detect that it's in Kubernetes by looking for some very, very common, well-known environment variables. Okay, so there's my application started on port 8081, and it's obviously drawing its configuration from the config tree, which is, it's got all of this. If we go to the info endpoint, sorry, Ian, is it? Oh, I think I disabled it, didn't I? Info.message. Actuator info. Oh, it's the port 8181. Okay, there you go. There's the the arabjug.yaml. That's the Kubernetes version of this. Okay, so we have an application. We have Kubernetes specific configuration properties. We can also have Kubernetes specific configuration beans. So, for example, maybe this bean doesn't make sense unless you're running on Kubernetes. Okay, great. So you can just use the same kind of thing. You have an annotation here that makes this bean dynamically configured for just a particular environment. Same thing for this. I could have this custom health indicator that only exists on Kubernetes. Okay, let's see an example here. like that. Runner, turn new application runner, and just say, hello Kubernetes. Okay. Good. And now we can just restart this. So we should see that this will print out hello Kubernetes. Okay. But what about this one? Let's see. Now if we get rid of the property, apply, hit OK, reload. And we don't see anything there. Okay. Good. So we have an application that has dynamic configuration. It's observable. The configuration is unique to each environment. There's a lot of different opportunities here. Obviously, I don't recommend that you change your beans for just a particular cloud environment. You shouldn't do that unless you have to. It's just nice to know that you could if you needed to. Okay. Now, what I want to do is I want to take this application and get it to production. And in order to get it to production, I need a couple things. First, I want to turn it into a container, like a Docker image or something like this. And then finally, I want to, let's see here. Finally, I want to turn it into a native image, a GraalVM native image. Okay, so let me see. Sorry, friends. I want to turn it into a native image, and the way I'm going to do that is I'm going to use GraalVM. Now, GraalVM is an OpenJDK replacement. It's a hotspot, just-in-time replacement. By the way, you can still hear me, right?
Yes, Josh, we can hear you. Yeah.
Thank you. My iPad, the headset here to my iPad. I was like, oh, did it switch? I hope not. Okay, so we want to turn this into a GraalVM native image. GraalVM is a OpenJDK replacement. It is a replacement for Hotspot, the just-in-time compiler. The just-in-time compiler was built to take your frequently executed Java code and turn it into native architecture and operating system specific binary code. Okay, this approach means that Java can actually sometimes be faster than equivalent C or C++ code for two reasons. One, Java can see all of the memory in the application, right? Whereas if you are managing the memory by yourself in your C or C++ application, then you have to do something called resource acquisition is initialization. Basically, RAIA, right? It's an old pattern. RAII, right? It's a pattern that you learn when you do C and C++. And what this means is that your program has lots of like memory acquisition and then destruction, memory acquisition and destruction, lots of bursts of memory all throughout the program. Whereas with Java, it can just put everything into this one big space and clean it up as it needs to in the background, right? It doesn't stop what you're doing in the middle of your processing. That's one reason. The other is because of this just-in-time compilation. Java can see that you are executing certain parts of the code many successive times. And because you are executing the same code multiple times, in certain scenarios, it can just take that code and turn it into native code on the fly, right? On demand, which is amazing. So you can get native performance without writing native code. And this is great. But if native performance is so great, then why don't we just take the whole application and turn it into native code before we deploy the application? Well, of course, in the early days of Java, with the write once, run anywhere, that would not have worked, right? We wanted to make sure that our Java applications run on all operating systems. But if you are running a Linux container with a Linux binary on a Linux host running on top of Linux servers, on top of Linux virtual machines, on top of a Linux world, I just wanted to work really well on Linux, right? I think that's true for a lot of us. I'm not worried about somebody using my code in an applet that will run on Solaris, or BSD or something like that, or maybe some operating system with a different, little Indian, big Indian encoding or something like that, right? All I want is it to work well on Linux, right? So this is very important to me to take full advantage of that context of that operating system. So GraalVM's AOT compilation stands for ahead of time compilation. and it'll proactively, I mean, before you deploy, before you compile, or as you're compiling, it'll turn the code into architecture and operating system specific binaries. Now, this works well, but remember, in order for this to work, it has to make some optimizations. One of the things that it does is it looks at your code and it decides what code is reachable, right? It looks at the very beginning of your code and it says, oh, you're calling this method on this object. Therefore, that method, that object, we will keep that method. And that method is also calling this object with this method. So we'll keep that one as well. And it goes through the graph and it keeps everything that is being used by something. But if nothing appears to be used at compile time, GraalVM throws away that code. It doesn't keep the definition of the class or the methods or anything in the memory for the native heap. This is a problem, however, because Java is very dynamic, very, very, very dynamic, much more dynamic than C or C++. It's more like Lisp, right? With Lisp, I can change my runtime at runtime. I can change the environment in which my code executes while my code is executing. And the same is true for Java. I can add new classes to the class loader after the application has started, right? I can redefine types. I can create new types from nothing. I can do all sorts of things. In fact, it's possible in Java today to write, to have a Java lang string variable that has as its contents class, cat, curly bracket, and then quote, right? So it's actually it's a class definition of sorts, right? You can take that string and compile it into a .class file, write it to the file system, read that file into the class loader, load an instance of that class using reflection, create a JDK invocation handler and proxy out of it. You can serialize it if it implements serializable. And you can do all of this after the application has started up. This is amazing, right? It's absolutely amazing because Java can do very dynamic things, just like JavaScript and Ruby and Python and Lua and all these other languages, right? You can do the equivalent of eval. And this is one of the reasons that Java is so amazing. It's because of all this dynamic capability. Remember, Java has been around since 1994, 1995. That's like 27, almost 28 years that people have known about and worked with Java. That's a long time. And the reason it is so popular is because you can do all these amazing things with it to accommodate lots of different use cases. But the problem is that GraalVM cannot understand, it doesn't see all this dynamic behavior. So you have to feed it configuration files. And these configuration files tell it when you're going to create a proxy, when you're going to do reflection, when you're going to load a resource from a jar, when you're going to do serialization, when you're going to call a native method, all this stuff that it needs to know about, you have to provide configuration for. Well, this can be a lot of configuration if you're on the Java ecosystem, because everything does reflection, everything does all these kinds of things. So you have two choices. One, you provide the configuration, or two, you reduce the need for the configuration by doing less of these things. And so we have created a project called Spring Native. Spring Native is a research project. It's a separate project from Spring Boot and Spring Framework that proves the concepts around, building native images out of Spring applications. But it's not the end of the line. It's not the end of the journey. You see, the goal is to take all of this work that we have done since 2019 and to merge it into Spring Framework 6.0, which is coming out this year. So Spring Framework 6 is the next generation of Spring Framework, and Spring Boot 3 will be built on top of Spring Framework 6. Spring Framework 6 has many amazing new features, including a revised perspective on observability, including integration with the latest Jakarta EE baseline revisions, including the new package, right, Jakarta.*. It has a new baseline on Java 17, so it will no longer support Java 8, which is yet another reason why you should be using Java 17. And by the way, if you're stressed out about this, consider the timeline of Spring Framework revisions. Spring Framework 5 came out in 2017, 5 years ago, almost 5 years ago, September of 2017. By the time that Spring Framework 6 comes out, it will have been more than 5 years, which is a long time. So think about that in the future, right? By the time Java 17 and 18 are already out, by the time Spring Framework 6 comes later this year, Java 19 will be out. So then you add 5 more years. And remember, there are new releases of Java every 6 months. So 5 years is 10 releases, right? So we could be at Java 29 by the time you see Spring Framework 7 or something like that. So Java 17, in the context of a half decade and that large horizon, is not very aggressive at all. It's actually a very, very conservative, very baseline revision. And I think it's reasonable for people to just move their code to Java 17. It's much better. It's better in every way. Okay, so Spring Framework 6 has observability, new baseline revisions, and of course, this AOT and native image support, okay, just built into the core. Spring Boot 2 and Spring Framework 5 can continue to use Spring Native, but the real goal here is to take existing applications and make it easy to move to Spring Boot 3 and Spring Framework 6 and get native support out of the box. This is a big deal, but there are some interesting opportunities if we do that. So we have this project, Spring Native. We're using it right now. I want to take this application and turn it into a native image, okay? So I'll go to my command line here, Maven, skip tests, clean package, and I want to use the Maven native profile. So that'll take, I don't know, a minute or so, and it'll compile my native application, and we can then run it. I'm using a Mac, so obviously this binary won't be very useful in my production environment, but it does work, right? I can run it on my local Mac just to prove that it compiles. If you're using GraalVM on GitHub Actions, there's a very convenient GitHub action that you can use on GitHub Actions to do matrix builds. So you can build a Linux binary, a Mac binary, a Windows binary, all in the same CD pipeline. You know, it'll run the same build multiple times with different operating systems underneath. And so that way, at the end of the pipeline, you can upload, you know, different binaries for different operating systems and so on. Most people don't need to do that, but if you do, then at least you can, right? Most people just want to take their native Linux binary and then deploy it into a Linux container on their Linux host. So let's make sure that this works. First, I'll just drink some water. This takes a little bit of time because remember, it's doing analysis not just of your code, but all of the dependencies on the class path. Okay. So target customers, this first time is slow because it's going to ask permission here, okay? Can Control C, there we go. So there's our application, 73 milliseconds or 73 1,000ths of a second, right? That's faster than the blink of an eye. It's very, very quick. And more importantly, it's also very, very small. So if I look for this binary, there's the PID, PID equals, okay, env bin RSS by PID, okay? So it's 100 megs of RAM. On Linux, I find the binary size is much smaller for some reason. I don't know why on Mac it is bigger, but you know, either way, this is still very small. You can put that in like out, and this also doesn't require a JRE, and it doesn't require a full operating system, right? You don't need everything that's required to run all of the JRE because you only need the minimal stuff that's been compiled into the native image. So you can use Alpine Linux to build a native binary, a native container that will run this. Very, very efficient, right? Very, very small container, 120 megs or something like that. Now, building a container is, of course, very important. And the way you would do this is you use build pack support. Build packs are a way to take your application artifact, your source code or your artifact, and turn it into a Docker image. So if you're using Spring Boot and you have a jar, or if you're using, if you give it a .war or a Python application or Ruby on Rails or Java, Node.js or whatever, you can take any of these applications, and turn them into a container automatically. Why do we reinvent this stuff each time, right? We should not reinvent the recipe to containerize a Java application. There's only so many different ways to do this. It's not very interesting. And so build packs are a recipe to do this for you so that you can avoid writing Docker files and just go home, see your family, have some tea or something, life is too short. Don't write Docker files. So these build packs, this is a cloud native computing foundation. It was created by the Cloud Foundry team who took their work and based it on Heroku's work, right? So this was Heroku first, then the Cloud Foundry team. We got together, we merged together to work on this. We created cloud native build packs and initiated it in 2018. It was and then we joined the Cloud Native Computing Foundation in 2018. Okay, so this is a very useful project. There's a lot of different builders for lots of different languages and runtimes and so on. You can use the pack CLI, no problem, but you can also just use the Spring Boot support itself. So if I go here, customers, I can do Maven, skip tests, Spring Boot, build image. Now, this will work just fine on any Intel computer, on a Mac, Windows, or Linux. I am running on an Apple M1, okay? And Apple M1, there's a small issue, okay? And so this won't work here, but you can fix it by building your own builder, okay? So what I'm gonna do is I'm gonna copy and paste a custom builder that a colleague of mine built and just paste it into our code here. So go back up here, paste that custom configuration for the builder. Whoops. There you go. And this will work on ARM, the architecture type ARM, okay? So there we go. Now we can say Maven skip tests, clean Spring Boot build -image. All right. And by the way, if you don't skip the tests, it'll run the tests. It'll compile the code in the tests and then run the tests as native images. And that's great. Obviously, you want that because that way you know that your code works well in the native world, right? But that doubles the compilation time. So instead of taking 1 minute and 10 seconds, it'll take 2 minutes and 20 seconds, which can be a long time for a demo on stage in front of a large group of people, as I am right now. So I tend to skip it. But just know that that is there. There is pretty good support for testing, but there are some things that you may want to do in a test context, like Mockito, that is not yet perfect. Okay, so keep that in mind. So this is going to compile a Linux binary, right? It's a Linux binary in a Linux container, and it's going to create that Docker image, and then we can Docker tag and Docker publish this to our favorite container registry, and that can be Google Container Registry or Docker Hub or VMware Harbor, right? Your cloud vendors, AWS and Google Cloud and Microsoft Azure, all have container registries of their own, of course. So you can use a lot of different things here. But the point is, you're not wasting time trying to figure out how to do this yourself, each microservice. Remember all that redundant infrastructure that I talked about earlier that Changi Airport does not have? Thanks to build packs and thanks to all the auto configuration in Spring Boot, you don't have it either, right? You don't have to worry about it, right? It's there, but you don't have to worry about it. It's just done in a consistent way. And the nice thing is, if you change this container, this builder, this Docker image for the builder, then everybody in the organization gets the new updated builder when they run the build again next time. So you can insert updates for security, you can change command line arguments, you can insert new instrumentation, and so on. So now, thanks to things like external configuration in Spring Boot, and even using things like Spring Cloud Config Server, I can keep my configuration for my cluster in a single place. I can use builders to centralize the knowledge of how to build those containers in a single place. And then, of course, Spring Boot gives you all this very common auto configuration so that most of the code that's required to write your application is out of mind. It's just a library on the class path, and it'll automatically do the work that you need it to do to build an application that is worthy of production. So let's see, this is almost there. Look at that, it's about to wrap up. Saving Docker library customers, blah, blah, blah. Okay, so that took a lot longer, right? Because it's building the Docker image, but let's run it now. Docker run. Okay, whoops, what happened here? Class is sealed. I don't know what this is. I think I did something wrong. But shouldn't happen to you. This is the first time it's happened to me, for that matter. Okay, well, either way, that normally works, and it should be just fine. What you get is a Docker image that you can take to production, right? And that's what we want here at the end of the day. Okay, so we've got an edge service, right? Did I close? I closed the process here. Yeah, I did. Okay, we've got an edge service. What? We've got an edge service. We got a service here, and that's ready for production. I think the only thing I would add is that you may want to create a edge service, a service that talks to this service. So you don't want all your downstream microservices to talk to every single one of your other services. And so it's very useful to have edge services. And here, there's some great technologies that you should look at. I hope you'll look at, like Spring Cloud Gateway and Spring for GraphQL. We don't really have time tonight to look at all of that stuff, or this morning. But if you check out Spring Tips, that YouTube channel, you'll find lots of stuff there that I have done looking at Spring for GraphQL and Spring Cloud Gateway. My friends, we've only just begun to look at some of the features today that will make it easier for you to build applications intended for production on Kubernetes. I hope you got something out of this. I hope you enjoyed yourself and learned something new. I am happy to answer questions right now, and I want to thank you so much for your time. It was a pleasure and a privilege for me, and I hope we can do it again.
Thank you, Josh. We would like to really thank you for doing this. And yeah, we can go for the questions. There are a couple of questions here. So what's the difference between liveness probe and readiness probe?
Liveness, good question. Readiness is when the application starts up and it's initializing itself. Readiness tells Kubernetes whether the service is ready to start handling traffic. If it's still initializing itself, maybe it's downloading stuff from a cache or something like that, then it's not ready to handle traffic. As soon as it is ready, then it gets put into production. Liveness tells Kubernetes whether the service is still healthy or not. If it is sick, if it is not working well, then it's not live, right? The liveness probe says it's down. Otherwise, it says it's up.
All right, moving on. So in terms of the image size, what's the drawback compared to jars with dependencies?
Any drawbacks in terms of image size? Native image. Yeah, I mean, the native image, so when you use a jar, it doesn't have a JRE inside of it, right? You can use things like JLink. JLink is part of the JDK. You can create small JREs that you can use that are just sized just to run your code, right? And you can take away parts of the JDK that you don't need, parts of the JRE that you don't need. But unless you do that work, then you have to deploy a full JRE and all of your application dependencies and code. With the native binary, the native image compilation process automatically throws away all the stuff that you're not using in your libraries and in the JRE. So that native image is both the JRE and your code. So I think you'll find that it's, they're both they're not that bad. I think if you measured the cost of deploying a JRE and your application, it would be more space than the cost of deploying a native image, right? There is a thing you can use in the JRE called thin jars. A thin jar it's a thing that Dr. Dave Sire built, and what that does is it dynamically downloads all the dependencies when the main class is started. So you say Java minus jar, the jar is only a few kilobytes, but you say Java minus jar, it automatically downloads the Maven dependencies when the application starts. So the deployed container is super small, like it's just the JRE and then a few kilobytes more. There's things you can do to make the JRE small with JLink. You can use thin containers for your Spring Boot app, or you can just use native images. There's lots of tricks you can do. I don't know all the numbers offhand.
Awesome. All right. We have a great talk. It's like a kind of a compliment. What use cases benefit from the native option?
Well, like I said, the applications take up very, very little RAM, right? That's the most important thing here, is that they take up very, very small footprints. So you can take our goal, what we want is for you to take applications from 5 years ago, 10 years ago, upgrade them to Spring Framework 6, and then take advantage of native, right? And we are trying to make it as easy as possible to support that use case. The goal is you can take code from a long time ago, compile them to native, and get the benefits of that reduction in footprint, right? So imagine most Java applications take 500 megs of RAM. I mean, pretty conservatively, right? Sometimes even more, right? I remember 10, 15 years ago, I would ask people, how much RAM are you using on the JRE? And they'd always say, 1 gigabyte, 2 gigabytes of RAM. And actually, people wanted to use more, right? This is back in the days of application servers and all this kind of stuff. They wanted to use more RAM, but the problem was that at the time, the JRE was 32-bit, and it was very hard to garbage collect more than 4 gigs of RAM. And so, or 2 gigs and then 4 gigs, right? There's like a limit there. And so now it's 64-bit. Now it's very easy to address a much larger block of RAM, but it's still not very efficient to do that, right? But so the goal is not to get bigger like we tried to do 10, 15 years ago. The goal is to get smaller, especially since you have to pay for the RAM that you use in cloud vendors these days. So let's keep in mind that nothing is perfect, right? When you use native compilation, the garbage collector is not as fast as the JRE garbage collector, right? Not yet. Maybe soon, maybe one day, I don't know. It'll become as fast, but it's still fast enough. And let's just do very simple math, okay? Let's say that, and again, I'm making these numbers up so we can kind of understand. Let's say that your JRE application handles 10,000 requests per second, okay? But your native application can only handle 7,000 requests per second. So you've lost 3,000 requests per second. But the native application it takes 100 megs of RAM or 50 megs of RAM on Linux to run instead of 500. It's now 1/10 of the footprint of the RAM of the JRE application. So you can deploy two native images. Now it takes 1/20th of the RAM of the JRE application, and now you're handling more than you could handle before. So one instance before 500 megs of RAM. Now 2 instances, 100 megs of RAM, something like that, right? And so you can handle the same number of requests per second or more, and it's still a very, very huge reduction in memory footprint. So that's, I think, the biggest feature. There's also fast startup time, but unless you're doing serverless, that doesn't really matter. that's not a thing I care about that much, and especially when you're doing development, because it takes a minute to compile, right? So you know the cycle time, you know, and Spring Boot apps these days, they start up really quick anyway on the JRE. Even if you don't do native, they start up super quick. You saw most of the time. What was it here? If I run this right now. Okay, so like less than a second, it's 900 milliseconds, and I've got the screencasting software running and all that stuff.
All right.
So, you know, I hope that answers your question.
Ghazi says thank you very much for this
Thank you.
presentation.
My pleasure.
Same
Thank you
thing
so much.
here. Thank you. And yeah, that's all. I would like to really thank you again for doing this wonderful presentation. I personally enjoyed it a lot, Josh. And
My pleasure.
yeah, hope to catch up with you sometime soon. And yeah, that's it. I want to thank also everyone who tuned in. Hope to see you soon in the next session. And have a good day, everyone.
Thank you, everybody.
Thank you, Josh.